Now, the last topic I want to cover in the context of memory is that of the constructive or reconstructive nature of memory. Let me give you an example. Look at this image. Which is the good penny? And it's a pretty hard task. Every time I do this in class, I get a number of responses, and it's hard to find which is the right one. And to probably what you're doing right now, you might have a sense, you might have a converged towards one of these. But now what you're probably doing is you're looking at them and you're thinking, okay, so I know there's the head of Lincoln. I don't remember, does he look right or does he look left? And then, yeah, there's written in God we trust, or is there written United States of America or E pluribus unum? Isn't there written 1 cent on the side or is it on the other side? I forget. Right, and is the date on this side or is the date on the other side of the coin, on the verso? So probably what you're trying to do right now is you're trying to reconstruct what a penny looks like. You know the components. You just don't remember it kind of in that DVD sort of way where you just sort of inspect your memories and you see an image. You know what makes part of a penny, and you try to sort of reconstruct what it might look like. If you wanted to know, this is the right penny. Now, if you ask people to draw from memory what a penny looks like, it's awful. People are terrible at this. And it's not like we don't use pennies all the time. And if you look at the drawings in particular, what stands out is the fact that clearly people know the components. You know, yeah, there's a face. There's some sort of face. Maybe it's beardy. And there is something written on the sides. I can't quite remember if it's 1 cent, a pluribus unum, in God we trust, or United States of America, or maybe 1 penny. Maybe the face looks straight at me. The components are there, but how exactly they match? You know the components. You don't see the penny in your mind the way it actually is. And now, if you're thinking, oh, well, I just never use pennies, I only use credit cards and Bitcoins, fine. No cheating, okay? Eyes on the screen. Which one's the right one? It's tough, right? Because you know the ingredients. So obviously there's an apple. The apple has the little stem on the top, but is it going left or right? Right? What side? And then how about the bite? Is the bite on the right or the left? And does the bottom of the apple, does it have that little sort of cleft, or does it not have it? It's pretty tough. In fact, when our own Alan Castell and Adam Blake did this experiment, turns out only 47% of the people could remember, could correctly, identify the Apple logo. By the way, from now on, if you want to be able to identify it, Steve Jobs was left-handed. So he always imagined grabbing the apple from the left side. So when he bites it, the bite would be on the right side. So this way, you can always recover the right Apple logo. And if you ask people to draw it, same thing, terrible. In fact, sort of when they rated these drawings, only one participant out of 85, and these are not 85, participants that maybe have seen an Apple logo. These are 85 of you from UCLA who were asked this, and less than half could identify the right one, and 1 out of 85 could sort of draw it in a way that it was recognizable enough in the sense of its features. And I mean, you can't say that you're not seeing the logo of Apple everywhere in your life. You've probably seen it 50 times, in this last hour. Okay. But that's just not how our memories work. Our memories are definitely not DVD players that sort of you burn stuff on it and then you can kind of pull it out and look at the images. That's just not how it works. The way it works is that every time you try to recall something, what you're actually doing is not conjuring something that is in there and that you can inspect to see if it matches reality or matches some information that you're interested in, you're reconstructed. You're reconstructing what the memory is like, exactly as in the case of the penny. And see, so the problem with doing this is that this must mean that our recollections are based on inferences. They're not based on what we had seen. They're based on events that happened after the event that we encoded and that we're interested in recalling, events that happened before that event, the stuff that we know, the stuff that we like, the stuff that we don't like, prejudices. All of these things play into reconstructing our memory. And so the problem of the fact that memory is reconstructive is that it just makes it extremely susceptible to incorrect reconstruction. And there are a couple examples that I wanna show. Now, one is known as the DRM paradigm, from the name of the three scientists that described this. And the idea goes something like this. So you're a participant in a memory experiment, and you get to hear a list, and you have to study it and commit it to long-term memory. So in this case, we have bed, rest, pillow, slumber, awake, alarm, snore, etc., etc. And you're probably noticing that they're all categorically related. In fact, they all relate to one word in particular, the word sleep. All these words are hinting at the word sleep. Sleep, however, is never presented. Now, then you have a recognition test. So you're shown a number of words. Some of them were in the list, some of them were not in the list. But the key is that the critical item is the word sleep. As I said, all of these words are hinting at sleep, although sleep was never presented. How do people react when they see the word sleep? Do they think they've seen it or not? Turns out, more than 40% of the time, people actually reported that they had seen sleep, that sleep was one of the words that they had studied. In fact, they reported sleep almost as frequently as words that actually were on the list. In the sense, you've been implanted a memory. Just by framing this list, the scientists implanted a memory, the false memory, that they had seen the word sleep in their participants. And this, incidentally, also provides some support for the fact that long-term memory must be organized in some kind of semantic and categorical type representation, as we have seen earlier. Now, perhaps the most famous scientist in this context is Elizabeth Loftus. She has done milestone after milestone experiment to demonstrate how tricky our memories are. And she's particularly interested in the context of application to eyewitness memory. So sort of in the legal, in the case of trials, and in the case of eyewitness testimonies. Now, in fact, she found that it's fairly easy to implant false memories into people. And this is an effect that she called the misinformation effect. Let me show you an example, a key example. Now, Loftus and Palmer, they showed participants in a study videos of car accidents. And right after seeing the video, participants were asked to guesstimate at what speed the cars were going when the accident occurred. Now, what the clever twist of what she did was that she changed the word with which the question was asked. So sometimes it would be, how fast were the cars going when they contacted each other, sometimes they hit each other, sometimes collided, and sometimes smashed into each other. Turns out, you'd think this couldn't possibly affect what you've seen with your eyes, but memory is reconstructive. Turns out that if you heard the word smashed, your average guess as to how fast they were going is perhaps just about 41 miles per hour. When you are asked a question with the word contacted, the average guess is 32 miles per hour. That's a huge difference. That's a 10 miles per hour difference in the average estimation of how fast those cars were going. And it's the same exact cars. It's the exact same video. All that changed is the word that was used to elicit the answer. In fact, even worse, if you bring people 1 week later back to the lab, although this was a different experiment, but that's how the setup worked, and you say, oh, by the way, I forgot to ask you, did you see any glass on the ground when there was the accident on the scene of the accident? And they had 3 different groups. One group was a control group, meaning they saw the video, but they were not asked to provide an estimate of how fast they were going. And they, as a group, 12% of the time they said yes, there was some glass on the ground, and 88% of the time they said no. The group that was asked, how fast were the cars going when they hit each other, they responded just about 14% of the times, yes, I remember seeing glass, and 86, no. What is interesting is now you take the group that heard smashed, they reported 32% of the times that there was glass on the ground, 68% of the time there was not. Again, these 3 groups all saw the exact same video. All that changed was one tiny word in a question. So they didn't see it. They reconstructed that there was glass. And they reconstructed that there was glass because they were asked a question with one word different than everybody else. The word smashed versus hit, or versus no question. So now you understand how important it is to know how to phrase a question, because by changing my wording of a question, I can actually implant a memory, a false memory, in fact, in someone else with just one word. It's incredible, and it's an incredible demonstration of how reconstructive our memories are. Now, Elizabeth Loftus, in her incredible genius, came up with yet another wonderful example of this. And this, in fact, even stronger, it's the creation of false memories. This is the so-called lost in the mold technique, and it would work something like this. She would ask participants to refer them to their family, and they would get from the family 3 stories from the childhood of the participant. Then they added a 4th one, which was always false, about supposedly the participants, when they were young, they got lost in the mall. And so they read these little booklets with the stories, and they were asked to sort of think back to it. And then they were asked to generate as many details as they could of these memories. Of course, with 3 being actual memories and 1 being completely made up. Now, what's interesting is that 75% of the people actually rejected that memory, said that this never happened. I don't remember this happening. This never happened. But 25% adopted it and generated details about that story. Oh yeah, it was terrible. I remember I was really scared, and there were all these people around me, and I didn't know what to do. I was crying, and it was completely made up. So in a sense, you can see this as a form of retroactive interference, right? Information that you're getting later on is changing your memory for actual events that have occurred in the past. So again, sort of this lost in the mold technique has been shown now, has been used many other times now to show that even just the suggestion of an event and our imagination can actually lead us not just to alter what we know and what we remember, to actually entirely make up a new memory. And of course, you can imagine the obvious ramifications of this. It's a very difficult problem. Now, the last issue I want to mention is that of source monitoring. And this is sort of the idea of source monitoring is the inability to remember the true circumstance under which you've encountered and encoded a certain event. It's not always easy to remember when and where you've encoded some information. The most bizarre and incredible example of this is the example of Donald Thompson, which is the gentleman you see portrayed here on the right. Now, he was accused of having sexually assaulted a woman. And the victim, of course, reported a very vivid memory of it, as often happened, particularly for any type of memory that is very traumatic and very emotionally charged. However, at the very time that the assault happened, which it had happened, um, Thompson was actually on TV doing a live interview. So there was no way that he was the person who had committed that assault. However, he was on the TV. And so the act of her seeing him on TV retroactively interfered with her making the memory of the terrible assault that had happened. And somehow, in the process of reconstructing, it was the identity of Thompson who ended up being the assaulter. So what is again, this is sort of another example of how this is another form of retroactive interference. She did see him. She clearly saw him, but because of source monitoring, she didn't quite know. She couldn't remember what in the circumstance in which she saw him, and by interference, he ended up in a different memory. Effectively, again, he was implanted in the memory. Her memory for the event got retroactively changed. See, that's what's so striking, though. The fact that there's this tension between confidence that we often have for our memories, and it happens all the time, and whether they're accurate or not. The two, confidence and accuracy, actually dissociate very often. Now, one example of this in the lab, rather than just an observation of something that happened, was provided by Ross and colleagues in 1994. Now, what they did is they presented, they had two groups of participants. Half of them saw a video of a teacher in a classroom, and they saw the teacher, the students in the classroom, and in the corner, there was just a male observer that was observing the classroom interaction. The other group only saw the teacher and her class. Then, following this video, participants view an interaction in which the teacher had been robbed. Finally, they were presented with a lineup of males, including the innocent observer, and they were asked, do you recognize who it is that committed the robbery? Turns out, more likely than not, the innocent male observer, which was not the same person that had committed the robbery, was picked as the thief. And presumably, the only link that the observer had with the robbery was that he had been seen in temporal proximity with the robbery. So he had been seen in the video before. In fact, when the actual robber was not present in the lineup, people were even more likely to pick the innocent observer, which really suggests that people can just convince themselves that they remember something if there's no other memory available. So these are really incredible examples of how our memories, even if they feel very strong, very vivid, you remember details, you know you've seen that, actually turns out our memories are very reconstructive, which means they're very prone to interference and to error.